The Physical Sciences Oncology program encouraged us to look at cancer from a lot of different angles, because diverse perspectives contribute to a better understanding of this disease.
When I was considering where to do my PhD, the Physical Sciences Oncology Network I thought was a really unique draw for Cornell, and I was really interested in Claudia's lab for that reason, that she was so closely tied to this program.
Our center is really interested in better understanding how the microenvironment around the tumor cells is influencing tumor development, progression, and therapy response. So we're taking advantage of microfabrication, biomaterials, tissue engineering approaches, and advanced imaging to recreate and monitor how cells interact with their microenvironment.
We can actually grow the tumors outside the patient as an organoid that very much mimics the true tumor growing in all of its heterogeneity. We bring together the expertise of my laboratory with the expertise of the engineering department. We're transplanting these organoids into devices that allow us to monitor in great detail everything that's happening in that tumor, including its ability to be invasive into other tissues.
With the Meinig Cancer Center, we have an opportunity to have a direct connection to the clinic to understand how findings that we're making are relevant to patient outcome and to clinical care. And the Englander Institute for Precision Medicine in New York City is of great importance because they're allowing us to validate and test our findings with actual patient samples, bring that back to a precision medicine approach where we can then connect that to data sets that are generated from these patients. The center's work has been published in 161 publications and has been cited more than 7,600 times. We funded 16 new pilot grants that resulted in 52 new investigators to be recruited to our effort. We also collaborate extensively with other centers in the network, funded through 12 trans-network projects.
Doing work outside of the lab was actually very important for my career and developing a sense of thinking outside of the box and really forming partnerships that I still rely on today.
Over the past 10 years, we've trained 252 undergraduate students to graduate students and postdocs. We had participation by 50% male and female trainees and have also increased our efforts to enhance diversity, equity, and inclusion in our program.
We applied tools that weren't necessarily developed for studying cancer. Maybe they were developed for other purposes. People that appreciate the physical sciences have been able to lend their expertise to cancer research. And I think for a really long time, those voices weren't part of the conversation.
The collaboration that Cornell has with the Cancer Resource Center started about 6 years ago, and it's very inspiring for the students. It puts a face on a disease that they study in the laboratory at a cellular or molecular level. For some students, that impacts even their career trajectories.
We learned skills that aren't usually part of the curriculum. Things like empathy, reflective listening, and it taught us a disposition towards research that would never happen anywhere else.
Several students have become involved in our support groups at the Cancer Resource Center. Patients can ask questions about the science behind the cancer, and it gives the chance for the students to see cancer in real time, the ups and downs, the uncertainty. That's when the connection between student and patient becomes really strong, and that's been very, very exciting.
I'm really sad that the PSOC won't continue in its current form, but I do believe that the PSOC lives on in its trainees. It lives on in people like me who became professors, my classmates or my students and who are undergrads who became medical doctors, science writers, public policy. That's where the PSOC lives on.